This video will walk through doing a DOE using RCmdr to include creating the design of experiment, inputting the data back in, creating a linear model, as well as main effects and interaction plots. So for this example, I'm going to use data that I collected at Picatinny Arsenal in April of 2016. I was doing a study on landmines, and we were focusing on scatterable landmines, basically just spray an area with landmines. And we were looking at incorporating dummy landmines in with the live landmines to see how that impacted how people react to the minefield. So what we were looking at is you spray an area, and if it's high lethality, all the mines are live, and all of them will explode. If it's low lethality, half of them are dummy mines, so they're inert. There's no explosives in them. We also looked at minefield density. We looked at the number of mines per square foot and used that as a second factor in our design. So there are two factors, lethality and density. And for each of them, we looked at two levels. We built a test minefield in Picatinny Arsenal, and we ran 8 test subjects through this minefield and recorded the time it took for them to cross. We did each of the 8 test subjects crossed all 4 configurations. 4 configurations, again, we had 2 factors, and each factors had 2 levels, so 4 total design points: high lethality, high density, high lethality, low density, low lethality, high density, low lethality, low density. So now I'm going to go into RCmdr, and I'm going to build out the DOE. So first thing, let's load RCmdr. All right, so it's loading. All right, so it loaded. First thing we have to do, go to Load RCmdr Plugins, go to DOE, hit OK. It's going to ask me to reload. I hit OK, and it reloads. So the next thing I'm going to do is I'm going to create my design. So I'm going to go General Full Factorial Experiment. I have 2 factors, lethality and density. I have 8 test subjects. I always make sure to hit Repeat Only. Then go to Factor Details. So first thing, lethality. Number of factors, 2. I'm going to do low, high. Now I'm going to go to B. This is density, 2 factors, low, high. So it should look something like that. Now go to Export, CSV and RDA. I'm going to change the directory. I'm going to go to a directory on my desktop. I'm going to create a new folder. I'm just going to call it Mine DOE. Select that folder and hit OK. If everything goes as planned, I should be able to open up a CSV file that's at that location. And it's right there, so perfect. All right, so let's see how this looks. Perfect, so you can see that I have 32 rows because I have 8 test subjects and 4 design points. So let's So I'm going to add in a response variable, which is my transversal time. And this is going to be based off the data that I got at Picatinny. So I'm going to look at low lethality, high density, and I'm going to enter in the data. High lethality, high density. Low lethality, low density. And high lethality, low density. All right, now I'm going to save, close out of it, and I'm going to go back into RCmdr. So I'm going to go into RCmdr, Design, Import, Re-import experiment from CSV and RDA file. I'm going to change my working directory. Luckily, if you select that button, it normally takes you back to your working directory. hit select folder, select my RDA file, select my CSV file, and I'm going to hit OK. So I'm going to quickly hit View Dataset. This is a quick way to check to see if my file got imported back in. And you can see that my transversal time has been added on. All right, so now we're ready to do some analysis. So I'm going to go to Statistics, Fit Model, Linear Model. I'm going to do traversal time as a function of density plus lethality plus the interaction between density and lethality, which I annotate by doing density times lethality. I'm going to hit OK now. And what I can see when I come over here is that according to my linear model, the only factor that's relevant is the density of the minefield. Lethality was not relevant, and we can tell that from looking at the p-values, the final column in this table. We can see that with these stars right here and the very low p-value, density is relevant. And however, lethality, it didn't matter if there were dummy mines integrated into the minefield. People treated them like real mines, and it didn't really have a huge impact. But what did scare people was just the vision of mines, whether they were inert or not. And that kind of makes sense if you try to place yourself into a minefield and have that mentality. So that's the first analysis we're going to do. The second thing we're going to look at is main effects and interaction plots. So I'm going to go to Design, Analyze Design, Main Effects and Interaction Plots under two-level designs. So I'm going to look at traversal times. I'm going to put factors, click on Main Effects Plot, and hit OK. And my main effects plot pops up right here. What a main effects plot is showing is that for all the runs where the lethality was low, regardless of the density, the average was about 114. And for all the times the lethality was high, so all the mines were real, it was just slightly higher. Meanwhile, for density, all the times that it was low, regardless of the lethality, the traversal time was significantly lower than when the density was higher. Which again, this follows what we saw in the linear model. Let's now look at the interaction plot. So I'm going to close that, do the same steps again, main effects and interaction plot. But this time I'm going to select interaction plot. And I'm going to hit OK. I get something that looks like this. So what we saw in our linear model was that there was no real the p-value for that interaction effect was pretty low. And the interaction plot here is showing the same thing. So looking at the y-axis, this is the traversal time. And we're looking right here, so lethality is in black for high, red for low. So when density is low and lethality is high, we're looking at this point right here. When lethality was low and density is low, we're at this point right here. And similarly, when lethality is low and density is high, we're here. When density is high and lethality is high, we're at this point right here. So what we're seeing here generally is that the slope of these lines are pretty similar to each other. They're not crossing dramatically. They're not moving in. They don't have opposite slopes. And so generally, we would say that the interaction is pretty minimal there. All right, so we just did some analysis, and it's kind of useful to think about it for a second and just reflect, does this make sense? And again, like I said, if you put yourself in a minefield and try to put yourself in that mentality, it doesn't matter if the mines are inert or not. I would be scared. I'm sure you all would be as well. So it makes sense that the density is a critical aspect, the lethality much less so. It's always good to do that sanity check. And in summary, this showed you how to do a design of experiment using RCmdr.